Today you will be learning about direct variation, section 2-2 in your textbook. Direct variation is a relationship of two variables so that y equals kx, and k represents the constant of variation in the relationship. A real-world example: a person drives 45 miles per hour. The equation is represented by y equals 45x, where 45 represents the constant of variation, k. It can be found by y divided by x. For example, if I drive 100 miles per hour, or 100 miles in 6 hours, my constant of variation would be represented by 100 divided by 6, which is approximately 14 miles per hour. So in today's lesson, we will be looking at direct variation in concrete and real-world and abstract examples. How to identify direct variation. If we're looking at the table of y in a relationship with x, we see that when x is 1, y is 2, x is 3, y is 6, x is 4, y is 8. To identify if it's direct variation, we look at the relationship of y divided by x. 2 divided by 1 equals 2, 6 divided by 3 equals 2, and 8 divided by 4 equals 2. Since they all have the same relationship of 2, this does represent direct variation. The constant of variation, which is k, is going to equal 2, that relationship that we found by dividing y by x. So the equation is y equals 2x. So if I give you an x of 10, you can tell me y is going to be 20 under the same relationship. Another example with x and y. If x is 1, y is 4. If x is 2, y is 8. And if x is 3, y is 11. If we look at that same relationship of y divided by x, we get a 4, and a 3.67. Because of the 3.67, this does not represent direct variation, because there is not a constant among every single ordered pair group. How to solve direct variation. Suppose y varies directly with x, and y equals 9 when x equals negative 15. We want to know what is y when x equals 21 under the same relationship. So we set up a proportion with the first relationship of y equaling 9 when x equals negative 15. So 9 over negative 15. We want it to equal what we're trying to find for y when x equals 21. So we set up in the same order so that y's are both on top and x's are both on bottom. The same relationship as y divided by x. To solve the proportion, we cross multiply. Y times negative 15 becomes negative 15y equals 9 times 21 becomes 189. We divide by negative 15 to find that y equals negative 12.6. Another example. Once again, suppose y varies directly with x. Y equals 4 when x equals negative 2. Same thing. We do y divided by x, so 4 divided by negative 2. We set it equal to the relationship we want to find. What is x when y equals 6? This time, 6 goes on top and x goes on bottom, since we are looking for x. And once again, we cross multiply. 4 times x is going to create 4x. 6 times negative 2 is negative 12. Divide both sides by 4 to find that x equals negative 3. If you were asked what is the relationship between the first set and the second set, you could easily find that k equals negative 2. That is once again found by y divided by x. And the first one, y divided by negative 2 equals negative 2. And the second relation, 6 divided by negative 3, also equals negative 2. So as you can see here, the answers are y equals negative 12.6 and x equals negative 3.